this mini lecture, we are going to look at the idea of work. That's a nasty word, work. Nobody wants to do any work. What is work? What is work in the relationship of physics, and why do we even care about it? Well, we're going to do a very brief introduction of work, pretty much just defining it for us, but then recognizing that when we shift to energy, which we're going to talk a little bit more about, that those two things are related. That we need to understand a little bit about work in order for us to really appreciate energy. So work is a very basic idea that we're going to look at in physics. Work is really when we do work on something, it is moving that object through a distance, applying a force that causes an object to move through a distance. So if I'm going to do work on this eraser, I'm going to change that object's position. I'm going to change that object's location. I'm going to apply a force to get that object to move a distance. So in order to do work, first of all, I need a force. And if I provide more force on the object, I'm going to move that object in a different way than if I apply less force. I'm going to do more work when I move the object with a larger force than I do when I move an object with less force. The other thing is if I have to move an object a further distance, instead of just going a short amount, I have to move this eraser all the way to the other side of the board, applying a force over a longer distance. I'm going to do more work. So work is also related to the distance that the object moves. All right, now, how is work related? Well, we said if I increase the force, I increase the work. If I increase the distance, I increase the work. Work, fundamentally, is a force times a distance. Now, it's actually a dot product between the force and the distance. We're not going to worry about it too much, but what that dot product tells us is that there's something special about this force. So let's look at what might be special about this force. Let's take our eraser. Let's imagine that we have that eraser at a location in space. All right, now, if I were to apply a force of magnitude, let's say 5 newtons, I might apply that force in that direction, all right? Now, I'm going to take the same object, and I'm going to, it's close enough, I'm going to apply a 5 Newton force, same force, in that direction. And then, here's my third scenario, where I apply that 5 Newton force in this direction. Now, if I want this object to move a certain distance d, I want to do a certain amount of work on this object. Which force is going to be effective, the most effective? Well, you probably deduced that this force is going to be the most effective in getting that object to move that distance d. How come? Well, this one's easy to eliminate. Why does this not work? I'm not applying the force in the same direction as the displacement. So this force, that's not going to do it for me. That force will do no work. Well, this force, it's going to be able to move that object and do work on that object in that direction. But why is it less effective than this one? Well, only a portion of that force is in the direction of the motion, where the other portion of that force isn't doing anything, like we saw in that third situation. So effectively, I only have this small piece that does me any good. It's much smaller than my 5 Newton force. So what's related between this force and this small piece? Well, they're both in the direction of the distance. In this case, we're looking at the force that is parallel to the distance that the object is moving through. Well, how might I get this parallel force? If my force is acting at an angle theta, so an angle relative to the displacement, so here's the distance, here's the angle relative to that distance, then this parallel component becomes the force F times the cosine of that angle times the distance. And that's what we see as the result of the cross product. Rearranged two different ways. They represent the same thing. You might see them in both ways. But what we're representing is that this is the force in the direction of the distance moved. The displacement is our displacement, but because this is a dot product, we're going to talk about it as a distance. Now, that's the important piece about work, getting an object to change its location. The unit for work, well, we have the unit for force, which is Newton, and we have the unit for a displacement, which is the meter. So this sort of looks like a Newton meter, which was our unit for torque. Turns out this is not a Newton meter. I mean, it is a Newton meter, but it goes by another name. The unit for work is called the joule. So, our unit for work is the joule. Work is simply the force applied through a distance, and if there is no force in the direction of that distance, then there is no work being done. Now, even though this is a dot product and does not have a direction in the sense of right or left, we do have the direction of work in the sense of working in the direction of motion or working against the direction of motion. So, if the force and the distance are both in the same direction, so if force and distance are the same, we say that that is positive work. If the force, and again this is the parallel force, and the distance are opposite, we say that is negative work. So we are working with the direction that the object is moving, or you're working against the direction that object is moving. So let's take a little example of that. If I am applying a force to this eraser that I'm going to lift up, I'm applying a force in the direction of the object's motion. I'm doing positive work on that eraser. But what else is interacting with this eraser? Well, the force of gravity. And that's pointing down. It's pointing parallel to the force, to the motion. It's in the same dimension as the motion, but it's in the opposite direction. The gravity is working against what I'm trying to do. Its work is opposite. It's negative. It's negative work. It's working against. Conversely, if I am bringing the object down, but I'm slowing it down, I'm still applying a force in the upward direction. I'm working against the motion. I'm doing the negative work. Whereas gravity is the one that's pulling the object in that downward direction, in the same direction as the motion. It's doing the positive work. So it's really important to understand that the positive and negative aren't dependent on direction. It's dependent on how the force is related to the motion of the object, the movement, the displacement or distance of that object. All right, so real brief introduction of work just to give you a sense of what it is. We work on objects to change their location. And what we're going to look at next is then, what does that give us? And it gives us energy, which is really fun. So stay tuned for energy.